In your assignment, you will notice that there are a couple data tables, and this video will kind of illustrate, first off, how I got this data to begin with, but then it will also show you how to go about calculating the phenotypic ratios as well as the genotypic ratios. We'll also do a couple with the allele frequencies as well, and you also will need to use this data to explain to me how allele frequency, phenotypic ratios, and genotypic ratios support the theory of evolution. So you'll need to kind of use your data collected to complete this section. So to start with, you can see that there's 5 generations of mice. There's a variation in the trait of fur color, brown versus white. And we also have a table with the genotypes, as well as for the allele frequencies. Each has 5 generations, and as we can see, there are a total of 50 mice to start off the first generation. And that's because there was 100 alleles in the gene pool, and each mouse has 2 alleles, so 100 divided by 2 gives us 50 mice. Based on what you read in the introduction, you will notice that these mice happen to live in a brown, sandy environment, which would give mice that have a brown fur a higher level of fitness. They have a better chance to survive. That doesn't mean that the white fur mouse can't survive. It just means that it has a lesser chance to survive. So we're going to use a roll of the dice to kind of decide, does the white mouse live or die when it's running around on the brown sandy environment. And similarly, brown mice, they have a higher chance to survive, but they can also die too. So we'll use a roll of the dice to determine if a brown mice lives or dies as well. Now, to give the brown mice a higher advantage to survive, the only way a brown mouse will die is if I roll a 1. And to give a white mouse a better chance to die, the only way a white mouse will live is if I roll a 1. So that means that if I roll any of the other numbers, the white mouse will die. If I roll any of the other numbers, the brown mice will live. So to model how I got these numbers and to create kind of an equal playing field, what I did is I had created a deck of cards, each with an allele on it, like little b here, little b. These are the alleles. So this is the gene pool. There's 50 big B's, there's 50 little b's to kind of create an equal number here. And I would shuffle these up really good. And then I would just pull 2 cards off to see what kind of mouse I got. In this case, I got little b, little b. I got a white mouse. So what I would then do is I went back to my data table. I put a tally mark in the white fur column. I put a tally mark in the homozygous recessive column. And then I went to the dice roller to see what happened to that white mouse. And I click roll, and I rolled a 5, so that mouse died. I went back to my cards, and since this mouse died, I know that these 2 alleles will be removed from the gene pool. They will not go on to the next generation because these traits will not be passed to children. So I would take these cards and I would essentially just throw them away. I would pull off, my next 2 cards. Let's see here. Here's capital B, just to give you an illustration, lowercase b. And I would have a heterozygous brown mouse. So I would go back to my data table. I would record brown. I would record brown for heterozygous. And then I would go to my dice roller and I would roll the dice. If I roll a 1, this thing dies. But I rolled a 3, so it lives. So I would then take these cards. These alleles would go to the next generation. I would put them off to the side. I would take out my next one. Big B, little b. This is my next one. Let's see if this mouse lives or dies. But first, again, I did tally brown, heterozygous, dice roll, roll. This brown mouse lived, so I would go back to this. I would put it in my keeper pile. So I was separating the cards after I determined the mice. I was determining if they would live or die. I was recording. And at the end of my first generation, I had played all 100 of those cards, so this would add to 50. And when I was done, I had a pile of cards that survived, and I had some that I had thrown in the garbage. So as we move down, you'll notice that 35 and 7 adds to 42. That means I had 8 mice in the first generation die. All right. So the cards that survived, that would start round 2 or generation 2. I would go through those cards again, doing the same thing to record these numbers. When I had gone through the entire deck of cards, I had some cards I threw in the garbage, some that I threw in the keeper pile. I would take the keeper pile, start round 3, so on and so forth. So that's how I got this data. Now you need to use this data to calculate the phenotypic ratios, the genotypic ratios, and the allele frequencies. So let's do generation 1 for the allele for the genotype and phenotypic ratios, so you can see that. And then since allele frequencies generation 1 was done, we'll do 2 so you can see that. So the phenotypic ratio is a number that shows how many are brown fur, how many are white fur. And as we can see, that is 42 were brown and 8 were white. So that's a 42 to 8 ratio. But we need to reduce this. So I need to divide both sides by 8 to reduce this side to 1. So we can use a calculator online here. And we already know that 8 divided by 1 is 1, but what's 42 divided by 8? So let's find that out. 42 divided by 8 equals 5.25. So we would reduce this to 5.25 to 1. And that means that for every one white mouse we got, we were having about 5.25 brown mice. Not that you can have a quarter of a mouse, but it's just to kind of illustrate that there is more brown mice to white. There's 5 1/4 for every one. And you would need to repeat the same for these ones. Now let's look at the genotypic ratio. We have 8 homozygous dominant. We have 32 or 34 heterozygous, and we have 8 more that are homozygous recessive. And again, we need to reduce this. So to reduce this, we have to divide by whichever one of these numbers is the lowest, and that will take that number to 1. Conveniently, our lowest number is 8, and that's these two numbers, so 8 divided by 8 is 1. 34 divided by 8, let's see what that is. 34 divided by 8 gives me 4.25. 4.25, and then 8 divided by 8 was 1. So this was showing that for every one homozygous dominant brown mouse, I was getting 4 1/4 heterozygous brown mice and 1 homozygous recessive mouse. And you would need to repeat for these. Again, the lowest number in here is 7, so you would need to divide all these numbers by 7. The lowest number here is 2, so we need to divide all these numbers by 2, so on and so forth. Now, for the allele frequencies. Generation 1, we started with a total of 100 alleles, and 50 of them were big B, 50 of them were recessive B. That was the deck of cards I started with. So there was 100 total, 50 of them were dominant, so 100 divided by 50 is 0.5. My percent would be 50%. Same with these ones. But let's look at generation 2. That one's a little bit different. Let's look at how we got that. So generation 2, I had, let's see, I had 14 homozygous dominant mice. So that means that there are a total of, and I'm going to put this in parentheses, 28 Bs. 28 dominant Bs. And that's because each of these 14 mice has 2 dominant Bs. The heterozygous mice, they also have 1 brown B. So let's see here. That would be 28. Oh, no, I'm sorry. That would be 21. 21. So now I can find out how many total dominant Bs were in this generation. And so 28 plus these 21 would give me 49. So I would record that number here, 49. And let's see how many little b's we had. Let's see here. We had 7 that were homozygous recessive, and I know that each of these 7 mice has 2 little b's, so that would be 14 little b's. And again, the heterozygous also has 1 copy of the little b, so that would be 21 more. So 14 plus 21 is 35. So I would have 35 little b's. So I can see that this big B decreased by 1, this little b decreased by 15. So what is the allele frequency of the dominant allele? We would have to take 49 plus 35, which is 84. There are 84 total alleles in generation 2, 84, and 49 of them were dominant. So let's see what the allele frequency is there. We got, we'll take 49, how many we have, divided by the total, 84, and that tells me that the frequency is 0.58. So I can record that here, 0.58, which is 58%. So the percentage of the dominant allele has increased in this population. To get the frequency for the recessive, 35 divided by the 84, because there was 84 total. So 35 divided by 84, 35 divided by 84, 0.416. I'm going to round that to 0.42. So 0.42, which is 42%, which makes sense because 42 plus 58 gives me 100%. Perfect. This is what you need to do to calculate the allele frequencies for generations 3, 4, and 5, and then you'll have your allele frequencies, genotypic ratios, and phenotypic ratios that you can kind of explain how those changed to support the idea of evolution, which is what we're looking at in the guiding question. If you have any questions, definitely reach out to me. Don't sit there stumped. Reach out to me, and we can get you cleared up so that this is making sense and you can proceed successfully.